G'day everyone. What are probably the most common areas that we see relating through to the latent heat of change that we feel every day, every time we hop into a vehicle or get home and it's too hot or too cold, is refrigerant, like reverse cycle air conditioning systems or air conditioning systems in general. So we're going to have a look and understand exactly what is going inside an air conditioning system. We're going to be using an automotive one as an example, but it relates to every process that takes place whether you've got a reverse cycle air conditioning system at home. But we're going to be using an automotive air conditioning system to show you all the different components that can be used within them. Now, one of the areas that we didn't quite explore enough, and that is the fact that we used heat to heat up the ice when we were looking at that, our initial experiment, to change that ice from a solid into a liquid. Now, that absorbed 80 calories of heat energy. It then took 100 calories of heat energy to get from 0 to 100 degrees. But it took 540 calories to change from a liquid into a vapor. Now that's a really important thing, because what actually happens is that is the critical part that actually occurs inside the air conditioning system, and that is the latent heat of change from a liquid changing into a vapor, and that happens or occurs inside the evaporator inside the air conditioning system. So we're going to go out the back and just basically show you an example as to where we can use that with a simple exercise or simple little experiment. We know that we've got the four main gases that can be used that are extracted out of the ground. We've got methane, ethane, propane and butane. Propane is a gas that can be used inside an air conditioning system. It's called high chill. It's refined, much finer in comparison to just household propane. But it gives you the example of understanding that the fact that you can use one of these gases in order to be able to achieve the same process that happens within the refrigerant inside an air conditioning system. We're not going to be using propane, we're going to be using butane. And so butane is the bottom out of that range. So you've got methane, which boils at minus 196, ethane, which boils at minus 90, propane at minus 40, butane 0. And what that means is the fact that butane will change from a liquid into a vapor, but it will, as soon as it gets to 0, it won't continue that process. All your little lighters and your LPG burner, sorry, not your LPG burners, LPG is propane, but your gas burners that you've got those little containers, they're all filled with butane. So we've got a butane canister at the back. If you tip one upside down and push the nozzle down, the liquid will come directly up. And what we're going to do is an experiment showing you the latent heat of change from that liquid vaporizing to turn into a gas. And so that is really important to understand when you're looking at air conditioning systems, because that same process occurs within the evaporator. So it's a really important thing to understand. And so what we're going to do next is go through out the back and just do our experiment using the butane canister. And then we're going to go through the theory as to what happens with every one of the components within inside the air conditioning system itself. Then we're going to have a look and see what happens inside the heater box inside the vehicle, because that is actually really important to understand as well, because that is what is responsible for dehumidifying your windows on a icy cold morning where all your windscreens are all fogged up, and you'll get to understand that process more in depth. And the last video that we're going to go through is basically going through a machine that we've got to work and looking at all the various components that we've got associated with it. So it's quite a comprehensive series of videos that are coming up, but they're all well and truly worth that step-by-step progress as we go and watching them to get an overall understanding as to how air conditioning systems work. Okay, so we're outside now, and what we're going to be doing is measuring the change in temperature. I've got a tin and I've got butane. So there's our butane container. Inside is a liquid under pressure, not a huge amount of pressure. That's going to measure, or is measuring the temperature of that probe at the moment. And when I turn this butane canister upside down and just put that little point onto the edge of the tin, I'm going to release the butane into our tin. And we'll see a dramatic change in temperature as that butane is going to change its state. So if I get this right, keep an eye on the temperature. And it goes beyond the limitations of its capacity to actually measure. If I put that hard up against there. So we're down to minus 30 and it's gone out of range. So I'm not quite sure of the range, but we can see huge amounts of condensation have formed on the side of the tin. The butane has stopped boiling because its boiling point is 0. Propane is 40, as we just talked about. And so the probe has already gone out of its range. If I pour that butane onto here, that will boil. And it does. Okay, so now we've been through the understanding or the basic concept as to how the air conditioning system works. We're going to look at a system and go through and make sure we understand every one of the components that it, or every one of the stages as it passes through each cycle that the air conditioning refrigerant takes as it moves through the air conditioning system. The different components that we've got the compressor, we've got the condenser, we've got the receiver dryer, the thermal expansion valve, and also the evaporator. Now each one of these components has got its own particular task. The one that has been driven by the engine is the compressor, so that's where we'll start. So with the compressor clutch locked in and the compressor running, we're going to draw in a low pressure, low temperature gas. Now it's compressed from the low pressure into a much higher pressure, but it's still a gas. So it comes in at a gas and it goes out as a gas, but at a much higher pressure, and that in turn generates a huge amount of temperature. So to remove that temperature, it then passes through the condenser, and as it makes its way down through the condenser, as the name suggests, it condenses. And the reason why it condenses is the heat that has been taken away as the air is passing over the condenser reduces the heat to a point where the refrigerant changes from a gas into a liquid. Now that doesn't happen all at once, that happens progressively as it makes its way down through the condenser. So by the time it gets to its final stages going through the condenser, it should have turned into 100% liquid. It then makes its way into the receiver dryer, which is like a filter, and that also absorbs any moisture that might be in the refrigerant. It then makes its way up through to the thermal expansion valve, and then as it passes through the thermal expansion valve, it goes into the evaporator. The evaporator is located inside the machine or the vehicle, and that's the area that's the part that actually removes all of the heat from the inside of the vehicle. After that, it returns back through the thermal expansion valve and makes its way back through to the compressor. So the expansion valve, realistically, and there's a lot of different designs. This has actually got the receiver dryer, the refrigerant making its way into the expansion valve, but also the returning refrigerant passing through it as well. They don't all have that design, but this is probably becoming one of the most popular. Now, the liquid that comes out through and into the receiver dryer then makes its way up and through to an orifice, and that orifice is called the thermal expansion valve for good reason. They're monitoring and keeping an eye on the returning temperature from the evaporator, and therefore able to monitor and control the rate of flow of the liquid passing in through the evaporator. And they are able to open and close an orifice, which is obviously a small hole, and that small hole regulates the amount of liquid refrigerant entering in through to the evaporator. The pressure in the evaporator is much lower in comparison to the high pressure side here. And in doing so, that much higher pressure liquid vaporizes and turns into a gas. As it turns into a gas, it replicates exactly what we had a look at in our video that we had a look at with the butane. That massive amount of change from changing from a liquid into a vapor absorbs a huge quantity of heat energy. And that huge quantity of heat energy is what cools down the refrigerant inside the evaporator. So the refrigerant inside the evaporator is now very, very cold, and then that makes its way back in through the thermal expansion valve in this case here, where it then makes its way back in through the compressor. So that whole cycle of the refrigerant is a continuous one. Goes in the compressor as a gas, comes out as a liquid under high pressure and also high temperature, comes out the bottom of the condenser in a liquid, is filtered and also is able to reduce any moisture, and makes its way up in the form of a liquid to the thermal expansion valve. That is where it changes from a liquid into a vapor, and that massive quantity of heat energy is what is used in order to be able to cool down the inside of the machine. Then returns back in through the compressor. So that's just a brief overview of the basic concept as to how the air conditioning system works.